Good morning everyone. Today our presentation is talking about underpinning. Before our presentation, are you guys eat your prawns? Actually I'm not care are you guys eat your prawns or not. I'm just trying to make my video longer only. Okay, let's don't waste our time, just go through our presentation. First, we need to understand what is the underpinning. Underpinning is the process of strengthening and stabilizing the foundation of an existing building or other structure. Then, when and why underpinning work is necessary. Actually, underpinning may be necessary for a variety of reasons. First, uneven settlement. This could be caused by uneven rooting of the building, unequal resistance of the soil action of tree roots, or cohesive soil settlement. And then the second reason is increase in rooting. This could be due to the addition of an extra story or an increase in imposed rooting such as that, which may occur with a change of use. And then the third one is lowering of adjacent ground, usually required when constructing a basement adjacent to existing foundation. After we know when we need the underpinning work, now we need to know what is the function of underpinning. First one is transfer the road carrier by a foundation from its existing bearing level to a new level at a lower depth. And then the second one is underpinning or repairing a foundation when the existing foundation is unable to support the width of the structure or is not stable enough. And then the third one is to deepen an existing foundation. Fourth one is to construct a basement under an existing building. The next is strengthen a shallow foundation when a building with deep foundation is to be constructed adjoining it. And then the last one is to strengthen an existing foundation which has suffered from cracks or settlement.
For the function of underpinning is that it transfers the load carried by a foundation from its existing bearing level to a new level at a lower depth. Underpinning or repairing a foundation when the existing foundation is unable to support the weight of the structure or is not stable enough. It is also to deepen an existing foundation. It is to construct a basement under an existing building. It is also to strengthen a shallow foundation when a building with deep foundation is to be constructed adjoining it. And it is also to strengthen an existing foundation which has suffered from cracks and settlements. There are several types of underpinning to provide support for an existing foundation, which are bracket piles, helical piers, screw piles, hand dug piers, jack piles, and mini piles. All these types of piers and piles differ according to the installation, process, other materials used for underpinning, and the layout of the piers or piles. For bracket piles, it can be utilized for structures up to 2 stories high, which needs to depend on the weight of the building and the quality of the bearing material. Its maximum space does not exceed 8 feet. Space of piles depend on the load distribution of bracket piles, and this type of underpinning is economical only when both the existing and future structures belong to the same owner. For piers, it is good for long-term use as it offers a lasting solution to the foundation distress of buildings and structures. It is also very effective in emergency stabilization effort needed to quickly secure a structure from sinking. Screw pile. It provides a rapid installation because there is no need to mobilize special equipment such as crane with a pile hammer or a large drill shaft rig. It is inexpensive. It also has minimal site disturbance because the installation produces no soil cutting. It is easy installation on the batter. Can be installed in a wide range of subsurfaces conditions from very soft to stiff clays. Jack pile. This type of piles is most commonly used in underpinning structures. Once the soil underneath is excavated, a short length of pile can be inserted and jacked into the ground using the underside of the existing structures as reaction. Their method of insertion is by jacking. Jack pile underpinning is quiet, vibration-free, and flexible since the pile depth can be adjusted to suit subsoil conditions. Lastly, mini pile. It is the fastest method to install, the most economical to buy, thoroughly engineered, and it is least intrusive.
Helical pier is one of the most common underpinning methods, and it is easy to install and environmental friendly. So to install it, first, the holes are dug at the helical placement point to gain access to the foundation. Concrete will also be chiseled away if needed, and the spreader beam will be placed underneath the foundation. Second, helical pier is installed with hydraulic torque drive, a machine that would drive the helical pier through the weakening soil deep into the load-bearing strata to bear the weight of the structure. Third, additional extensions will be added to achieve required length. It will also be cut off to install the bracket. The bracket is placed underneath the spreader beam and connected to it to allow the foundation for lifting. Next, the pier will be connected to a hydraulic jack and the foundation will be slowly lifted. And lastly, the pier will remain permanently in place and the holes will be recompacted and the site is cleaned up. This process will be continuously done around the foundation until it's fully recovered. Now, let's take a look at this video of the construction process.
In this video, we'll be demonstrating the installation of Champion's helical pier system. To stabilize the perimeter of your home, helical piers will be hydraulically driven past the looser soil and deep down into the harder load-bearing strata. The weight of the structure will then be transferred off of these weaker soils and onto the helical piers. The process begins by hand digging holes at each point to allow access to the footer. Once the footer is chiseled and prepared, it's time to place the spreader beam. The spreader beam is placed underneath the foundation and will be connected to the Champion Ultra bracket later in the installation process. After the spreader beam has been placed, it's time to install the helical lead pipe. The helical lead is a steel pipe with multiple twisted helix plates ranging in size from 8 inches to 16 inches in diameter. The helical lead is placed in the footer hole in preparation for the hydraulic torque drive. At this point, the helical lead will be connected to a hydraulic drive assembly and the process of driving the helical begins. Designed to withstand 8,500 foot-pounds of torque pressure, the helical lead drills through the weakened soil, driving the helical deep into competent load-bearing strata. Once the helical has been driven, helical extensions will now be added one at a time, and the drilling continues until the helical is firmly and securely at the desired depth of installation. Once drilling is complete, the excess helical pipe is cut and made ready for the bracket installation. The Ultra bracket is now placed in position to the helical pipe and set underneath the spreader beam. Once the bracket assembly T-pipe is installed, we'll be able to seat the bracket directly onto the footer. The Ultra bracket is now connected to the footer and the foundation is ready to be lifted. The Fast Steel Ultra bracket is the industry's strongest foundation bracket. Each series of brackets are tested at the manufacturer and provide an unparalleled holding capacity of up to 120,000 pounds. Using a specially designed 20-ton jack assembly, we begin to slowly jack and lift the home's foundation. As the house is lifted, the weight of your home's foundation is shifted off of the damaged soil structure and onto the helical pier. Once we reach the desired correction, the jack assembly will be removed and the footer hole properly filled in.
After introducing the construction process of helical piers underpinning, I would also like to briefly talk about the underpinning construction process of the jack piles. To install the jack piles into the ground, first of all, they will need to identify the area needed to install the piles. After confirming the locations for the installation of the piles, they will have to excavate the soil surrounding the existing foundation of the building structure. After the excavation is done, the hydraulic jack will be inserted between the existing foundation, which will be at the top, and the concrete piles, which will be at the bottom. Once the hydraulic jack is in place, then it can be turned on and function to jack the concrete piles into the subsoil to reach to the desired depth. After the pile jacking work is finished, there will be a gap between the top of concrete pile and the existing foundation. Then the concrete will be filled into it to close the gap and form a thing called concrete cap. Lastly, when everything is done, the hydraulic jack will then be removed out of the soil. Moving on, let's watch a short video clip about the jack pile underpinning construction process to let you guys have a picture in mind of how it really works.
The ground below the foundation is dug out. A tunnel is excavated and workers pass under. The underpinning steel pipe pile press fit technique uses a hydraulic jack and press fits a steel pipe to firm ground inside the tunnel and raises the building through this counterforce. After this process is performed in multiple locations until the building becomes level.
Let's take a look at the advantages of underpinning. The amount of excavation required to permit accessibility is relatively small. Therefore, there will be minimal landscape repairs after the work of underpinning. Also, regardless of the cause or reason, the structure has to be supported from the bearing strata in order to avoid further settlement. The underpinning method is flexible and suitable for varieties of circumstances, making it the perfect solution for most of the problem. However, the cost of underpinning is relatively high, and the end result will heavily rely on the quality of product and also the skill of the contractors, making it requiring high level of supervision.
Problem occur during construction process of the underpinning. One of the problem is rubber foundation. The older building might use the large rock, which may be or may not be mortar together. This rubber foundation, which perfectly adequate for disturbing gravity load to the soil, are not well suited to bridging over underpinning pits. They lack the continuity that is inherent in reinforced concrete footing or even unreinforced concrete footing. Sometimes it may not be feasible to underpin this foundation. In some cases, it may be necessary to install a retaining wall next to the wall is designed to withstand the lateral force due to the surcharge. High water table with silts and clams. If the building around does not underpin, the drawn round of the water table will cause consolidation of the silty soils, which in turn cause settlement of this interior element. The interior wall will develop surf cracks and the slab on grade experience extensive settlements. As the result, the building was vacated. Sandy soil. The soil will settle when vibrated. The settlement caused by vibration of cohesionless soils can affect not only the foundation immediately bordering the excavation, but can also cause settlement of interior foundation and slab on grade. Besides, the sandy soil also will spill out. Cohesionless soil has no ability to stand vertically, so if sheeting or lagging is not installed as the excavation progresses, sandy soil will spill into excavation, causing the building lose foundation support.
One of the projects that use underpinning in Malaysia is the Pasar Seni MRT station. Pasar Seni MRT station located in Pasar Seni, the town centre of Kuala Lumpur. The station is named after the nearby Central Market, also known as the Art Market, and is located near the Petaling Strait. The area is known as the Chinatown of Kuala Lumpur. This underground MRT station is linked to the elevated Pasar Seni LRT station via a 65 meters pay-to-pay linkway. Beneath the station, a bus terminal is located there as well as a Rapid KL office. For the details of this Pasar Seni MRT station, the client and contractor of this project is the MMC Gamuda KV MRT Sendirian Berhad. The consultant engineer is the ACOM Sendirian Berhad. The scope of work of this project is Underpinning Micro Power and Temporary Social Power Works. The project value is actually 2.25 million ringgit, and also the start date of this project is September 2012 and the end date of this project is December 2012.